Welcome my dear learners for this course on engineering graphics. In module 2 we were discussing on orthographic projection of plane surfaces. In our previous lecture I have introduced to the concepts of orthographic projection of plane surfaces by 3 position method, and also we have solved problem number 1 and 2 of our discussion on orthographic projection of plane surfaces. Moving ahead, in today's lecture let us address problem number 3 and 4. The problem number 3 of our discussion on orthographic projection of plane surfaces states that a triangular laminae is of sides 25 mm is resting on HP with one of its corners touching it, such that the side opposite to the corner on which it rests is 15 mm above HP and makes an angle of 30 degree with VP. Draw the top and front views in this position. Also determine the inclination of the laminae to the reference plane. What he has specified is a triangular plane laminae of sides 25 mm is resting on HP with one of its corners touching it. So it is resting on one of the corners touching the horizontal plane. A triangular laminae is resting on horizontal plane with one of its corners touching it. Such that the side opposite to the corner on which it rests, is 15 mm above horizontal plane. If I measure the edge opposite to the corner on which rests is at a distance of 15 mm above the horizontal plane and makes an angle of 30 degree with VP. Draw the top and front views of this position. Also determine the inclination of the laminae with the reference planes is the question what he has asked. As we have already discussed, in the first position we won't show the inclination of the laminae with any of the planes. In the first position the laminae will be resting on horizontal plane. In the top view I can visualize the true dimension of the laminae. Now, as I already explained in our previous lecture, we are using left hand reference. That means that since it is resting with one of its corners, I should draw the triangle such a way that I will get the corner towards my left hand side. Correct? First let us draw the first position of problem number 3 what he has given, for which let me draw XY line drawn. Call this as X. We have vertical plane and horizontal plane. Let me call this as Y. Now let me construct a triangular laminae of sides 25 mm. All sides of the triangle are equal to 25 mm. Sides of 25 mm. What triangle have all sides equal to 25 mm? It is equilateral triangle. So construct an equilateral triangle of sides 25 mm such that you will get corner towards your left hand side. So for which I will construct an equilateral triangle such a way that I will get corners towards my left hand side, drawn 25. Now using compass I will construct the equilateral triangle. So cut 2 arcs. So this completes the equilateral triangle of sides 25 mm what he has asked. Let me call this as A, B and C, and each of this side is measuring 25 mm. Each of this side is measuring 25 mm. Now take the projection. So I taken the projection, draw very thin line, and observer will be here in the front view. So for the observer A and B is visible, C is invisible. So therefore mark this as A dash, B dash is visible, C dash is invisible. So show the laminae with thick line. Draw very thick line like this. So taken the projection, draw very thick line. Don't use any points. Kindly make a note, don't use any points. So this completes the first position. I drawn such a way that I will get corner towards my left hand side. Now in the second position I should show inclination with respect to HP, because in the first position the laminae is resting on HP. What he says, the edge opposite to the corner on which it rests, it is resting on HP with one of its corner touching HP, and the edge opposite to the corner is at a height of 15 mm. So therefore First let me mark A dash first. Let me fix A dash somewhere here. BC, that is B dash C dash, is the edge opposite to the corner A dash on which I will make the laminar rest, should be at a height of 15 mm. So therefore measure 15 mm height. So take a reference at 15 mm. I have taken a reference at 15 mm. This distance I measured as 15 millimeters given in the question. The side opposite to the corner on which it rests is 15 mm above HP. Now transfer the edge. So to complete lamina you take A dash, B dash, C dash. From A dash you intersect this 15 mm reference. Now you connect. This completes the second position, front view. So it is resting on one of its corner. As I clearly explained, on whether it is resting on corner or edge will be understood from the second position, front view. Second position, front view gives us the details. It is resting on one of its corner on HP. Now mark this as B dash, C dash. Now take the projection and complete the sketch. So take the projection. Intersection of B and B dash will be B in the top view. So till here I should take the projection. Intersection of C and C dash will become C in the top view. So till here I should take the projection. Similarly, intersection of A and A dash will become A in the top view. This will be A. So I got A, B and C. Now connect this with a dark line, because this is the laminae what we have. The equilateral triangular laminae is ABC. So draw very thick lines. Done. Now what is the final position that he has given? The final position is that above HP and makes an angle of 30 degree with VP. What is making an angle of 30 degree with VP? Again, if you check, it is resting with one of its corner touching it such that the side opposite to the corner on which it rests is 15 mm above HP and makes an angle of 30 degrees with VP. Anything given with respect to VP will be shown on HP. Now I should show inclination with respect to VP, correct? Here I have shown the details with respect to HP, because in the first position it is resting on HP. Rests on HP, inclination with respect to HP or details with respect to HP, then details with respect to VP. This is how we will solve. If the laminar rests on VP, then on VP, inclination or details with respect to VP, then details with respect to HP. Resting on HP, details with respect to HP, and then details with respect to VP. Now details with respect to VP is that the same edge which is at a distance of 15 mm above HP is making an angle of 30 degrees to VP. Which edge is at a distance of 15 mm? B dash, C dash. This B dash, C dash should make an angle of 30 degrees with VP. So therefore draw 30 degree line, draw 30 degree line, draw 30 degree line, and on this 30 degree line you ensure that B and C will come and lie. So drawn 30 degree line, this is what 30 degree line. On this line I want B and C. So BC is retaining its original dimension from the beginning, it is 25 mm. So mark 25 mm, mark 25, drawn BC. So this is C, this is B, right? So I'll pick and place it like that itself, which we have discussed in a previous lecture, because we have 4 different answers in the final position. That is, I'll pick and place it like this, or I'll tilt it such a way that A will come above, or I'll take 30 degree line like this and place it like this, or on this 30 degree line I'll place it such a way that A will come towards the bottom. So totally 4 answers you can give. Now to avoid confusion, we'll follow one method, that is, we'll pick and place it like this, such a way that always we draw the inclination clockwise in the final position, counterclockwise in the second position. Now you have to locate point A, measure this distance. Measure this distance. I am getting it as 17 millimeters. 17 millimeters is what I am getting. So this is a perpendicular bisector, right? So therefore mark this point as midpoint M. So mark the midpoint M on BC, that is 12.5. On 12.5 I am getting 17 mm. AM is measuring 17. AM is measuring 17. Draw 17. Drawn. This I will call it as M, midpoint. So that completes our point A. Clear? I replicated this here. Pick it and place it. This is A. Now take the projection and complete the sketch. So intersection of A and A dash will become A dash. Intersection of B and C is here. So this will be B and this will be C. So this is the required position. This is B and this is C. So this is B dash, C dash and A dash. So this is the solution for the given problem. And also he has asked what is the inclination with the reference plane in the second position. So this inclination is what he is asking. Let me find out that. So I am getting that inclination as 44 degrees. I am getting this inclination as 44 degrees is the answer. Here he has asked inclination of the lamina with the reference plane. The inclination of the lamina with the reference plane is 44 degrees. So this is the solution for problem number 3. Let me move for problem number 4, which states that an equilateral triangular lamina of 25 mm sides lies on one of its sides on HP. One of its sides on HP. The lamina makes 45 degrees with HP and one of its medians is inclined at 40 degree to VP. Draw the projection. One of its median is inclined at 40 degrees to VP. Draw its projection. So first I will have an equilateral triangle with on HP without showing any inclination to any of the reference plane. In the top you will get the equilateral triangle. Since it is resting on HP, in the second position I should show inclination with respect to HP, that is lamina is inclined at an angle of 45 degrees to HP. Done. In the third position I should show the inclination of the medium to HP. The medium is inclined at an angle of 40 degrees. Now towards left I should take side, means what? Edge. I should take edge towards my left hand side. It is not corner, it is resting on one of its edges. So take edge towards left. That is for the next problem. If I solve, take solution for problem number 4, drawn. Call this as VP and HP. Now I should take edge towards my left hand side, each of which measuring is 25 mm. So draw 25 mm. Done. Now use compass to construct the equilateral triangle. So 25 cut arcs. Now using which you complete the equilateral triangle. So connecting which I will get the equilateral triangle. So this equilateral triangle is measuring 25 mm. So since I want median, so take median also. So median will be at exactly center. So carry the median. Let me take that as M, A, B and C. Now take the projection. So if I take the projection, I'll get the laminae in the front view as a straight line. A is visible, B is visible, and C is invisible to the observer in the front view. Observer is here, correct? Now in the second position I should show inclination with respect to HP itself. How much is that? It is inclined an angle of 45 degrees to HP. The lamina is inclined an angle of 45 degrees to HP. So therefore I will mark the side A dash, C dash and measure 45 degrees. Measure 45 degrees, 45. Now transfer this laminae. How much is the length of this laminae? This laminae is measuring 22 millimeters. So draw 22 millimeters. Drawn. Laminae is transferred and I got point B dash. So this is what I transferred here, and this angle is 45 degrees given in the question. Now take the projection vertically and horizontally and complete the sketch. So take the projection. Intersection of C and C dash will become C in the top view. This will become A in the top view, and this will become B in the top view. So I got M, this is B, this is A and C. Draw very thick line because this is the laminae what we have. Done. Now what is the final position? The median is inclined at 40 degrees to VP. So I have to incline the median. So this median BM should be inclined at an angle of 40 degrees to VP. So to VP I want to incline it at an angle of 40 degrees. Now the question arises. So far whenever we inclined, the edge what we are inclining is retaining its true dimension from the beginning throughout the problem. Example, here BC is 25, here BC is 25, when I inclined BC is 25. No problem, solve whatever is given for us. But when the dimension is decreased, then what we have is the apparent length with us, but what he has given is for the true length. So this is the true length of the median BM, and this is the apparent length of the median BM. You can observe BM is larger in the first position, BM is decreased in the second position. Whenever we encounter these type of problems that we are getting apparent dimension when we proceed inside the problem, then we should always use apparent inclination. What do you call for the apparent inclination with respect to VP shown on HP? Yes, it is correct, it is beta angle. You solved it in orthographic projection of straight lines, correct? Apparent inclination with respect to VP is beta, apparent inclination with respect to HP is alpha. Alpha is shown on VP, beta is shown on HP, because anything with respect to VP will be drawn on HP, anything with respect to HP will be drawn on VP. Now anything that I draw on HP shows inclination with respect to VP, so apparent inclination with respect to VP that is shown on HP is nothing but beta angle. So this is a beta angle problem. What he has given 40 degree is for true dimension BM, but what I have is new dimension BM. Let me call the original one as BM1. I will call it as BM1. Now I will tell you how to get the beta angle. Observe carefully. First, let us lay down the true inclination given, that is 40 degrees is the true inclination given. So draw 40 degrees. First you draw true inclination 40 degrees. So drawn true inclination 40 degrees. There you draw a line. There you draw a line. There you draw a line. So this is a true inclination given. I will mark it as true inclination given with a different chalk. I call this as given 40 degrees. Clear? On this line, first true inclination is for true dimension, correct? True dimension is BM1. So mark B somewhere wherever you want. I'll mark B here. I'll measure M1. So BM1 true dimension, if I measure BM1 true dimension, it is measuring 22 millimeters. It is measuring 22 millimeters. So draw 22 mm on this one. 22 mm. So drawn 22 mm. I cut an arc for 22 mm. So this is 22. So this is what? M1. This is point B. So BM1 true dimension at true inclination drawn. Now fix the locus at this point. Fix the locus at this point. Fix the locus at this point. I want true locus. Fix the locus. And call this as locus of M. Call that as locus of M. Done. Now I want this apparent dimension and find out how much is the apparent inclination. For that, what you should do, you use compass and measure BM, keeping B constant, find out the new position of M. That is, I fixed B, measure the apparent M, BM. So fixed B, find out the apparent M point on this locus of M. So this will become new M for me. Clear? First I had drawn true inclination 40 degree and laid down true median BM1 22 mm and fixed the locus. Now fixing the same B, I will find out what is the apparent BM and find out the location of apparent M on this locus of M. Now connect these two. That will give us the perfect apparent inclination. Now I got BM. So using BM I can complete the problem. Clear? Now measure how much is the angle. Now extend BM to intersect the XY line back. So extend BM to intersect the XY line back. So I've extended BM and measure how much is the beta angle. So this will give you beta angle. So measuring beta at this point, you measure beta. So if I measure beta, I am getting beta as 55 degrees. So when you do in solid edge, you will get the accurate results. As of now, I am getting 55 degrees. Correct? Yes, I am getting 55 degrees. Now we complete the problem. So find out, using M you find out A and C. So for BM, AC is perpendicular, correct? For BM, AC is perpendicular and measuring 12.5 on either side. So draw a perpendicular line for BM with 12.5 on either side. So draw perpendicular at M with 12.5 on either side. Drawn, and call this as C and this as A and complete the sketch. Done. Now take the projection and finish the problem. So this is the intersection of C. We'll get C. So I have B, I have A here. So this is A dash, this is B dash, and this is C dash. Now join this, we'll get the solution, required solution. So A dash, B dash, C dash. So A dash, B dash, C dash is the required solution for the problem. So here we have measured how much is beta, and beta is found to be 55 degrees for this problem. This is how we should solve beta angle problem. So this is the solution for problem number 4 that's solved from this lecture. Thank you all.